Have you ever wondered how a mechanic can lift an entire car with just the push of a small handle? Or why a gigantic ship made of steel can float on water while a tiny coin immediately sinks? These amazing events may look like magic, but they're actually powered by the science of fluids. Every day, fluid principles help people build machines, transport goods, rescue communities during floods, and even provide safe medical care in hospitals. Today, we'll discover how hydraulic systems, Pascal's principle, and Archimedes' principle work together to solve real life problems. And by the end of this lesson, you'll be ready to think like an engineer and a scientist by designing your own simple investigation on floating objects. Have you ever noticed how a mechanic can raise a heavy vehicle with what seems like very little effort? The secret lies in a hydraulic system which uses liquids, usually oil, to transfer pressure from one point to another. Unlike gases, liquids are nearly impossible to compress, allowing them to transmit pressure efficiently throughout a closed system. This idea is explained by Pascal's principle, which states that pressure applied to a confined fluid is transmitted equally in every direction. Because of this, a small force applied to a small piston can produce a much larger force on a bigger piston, making it possible to lift extremely heavy loads with minimal effort. Hydraulic systems improve both simple and compound machines by making them stronger, safer, smoother, and more efficient. That's why they are used in hydraulic car lifts, excavators, dump trucks, garbage compactors, hydraulic brakes, barber chairs, dentist's chairs, and many other machines that make everyday work easier. Whether repairing vehicles, constructing buildings, or transporting heavy materials, hydraulics allow people to accomplish tasks that would otherwise require enormous physical strength. Fluid principles don't just power machines, they also explain many events we observe every day. One important concept is Archimedes' principle, which states that an object immersed in a fluid experiences an upward buoyant force equal to the weight of the fluid it displaces. In simple terms, the more water an object pushes aside, the greater the upward force helping it float. This explains why enormous cargo ships carrying thousands of containers can stay afloat despite being made of steel. Their wide hulls displace enough water to support their massive weight. The same principle allows fishermen to travel safely in boats, swimmers to float more easily in seawater than in fresh water, and life jackets to keep people above the water during emergencies. At the same time, Pascal's principle helps us understand how pressure applied to fluids makes machines more effective. Every time a driver steps on a vehicle's brake pedal, pressure travels through brake fluid to all four wheels, allowing the vehicle to stop safely. Dentists adjust examination chairs smoothly using hydraulic systems, while hospitals use syringes to inject medicine by applying pressure to fluids. Even something as ordinary as squeezing toothpaste from its tube demonstrates how pressure applied to a confined substance causes it to move outward. From homes and schools to businesses, transportation, healthcare, agriculture, and disaster response. Fluid principles quietly improve our safety, comfort, and quality of life. Now, it's your turn to become a scientist. Imagine you are challenged to discover what makes an object float or sink. You gather a basin of water along with several everyday materials such as clay, aluminum foil, bottle caps, wooden blocks, and metal objects. Before placing each object into the water, make a prediction. Will it float or sink? More importantly, why? Then begin experimenting. Try changing the shape of a lump of clay from a solid ball into a shape of a small boat. Even though its mass stays the same, you may notice that the reshaped clay suddenly floats. Why? Because changing its shape increases the amount of water it displaces, creating a greater buoyant force. You can also compare objects with different masses and volumes to observe how these physical properties affect floating. Through this simple investigation, you'll practice asking questions, making predictions, collecting evidence, analyzing results, and drawing conclusions. The same scientific processes used by engineers, researchers, and inventors to solve real world problems. The science of fluids is all around us, from hydraulic machines that lift enormous loads to ships that cross oceans and rescue boats that protect communities during floods. Pascal's principle and Archimedes' principle help engineers design safer, smarter, and more efficient technologies. By exploring these concepts through observation, experimentation, and creative design, you're not just learning science, you are developing the curiosity and problem solving skills needed to shape a better future. So keep asking questions, keep experimenting, and keep discovering because every great innovation begins with a simple scientific idea. Science is all around us, and your next discovery could change the world. If you enjoy this lesson, don't forget to like, share, and subscribe for more exciting science adventures. See you in the next video.